Hey, Jonathan here. Today we're going to be doing a very simple blockchain Web3 app with Flutter that uses a very simple smart contract um, and an Ethereum blockchain running locally on Ganache using the Truffle development environment and Web3 Dart. So let's get started. So let's first create a Flutter application. Flutter create first DApp. Now we can open the folder. First DApp. And in the meanwhile, if you don't have it already, you can go ahead and download Ganache and have it installed. And we need to install Truffle globally. So this is our development environment, which allows us to compile and deploy Solidity into the blockchain. So now Truffle is installed. We can init a Truffle environment within the same folder as the Dart project. And this is necessary because we're going to be loading the Truffle generated files into assets of our Flutter app. Now it's asking whether to overwrite test. For this example, it's okay because we're not going to write Flutter tests. But if you do have them, you can solve that on your own. So now we can see the contracts folder that was created, as well as migrations and the Truffle config down here. And we can start by running the Truffle create contract. And we're going to create a contract called life meaning, which is very simply going to save the specific number that represents the meaning of life. So now we can see it created here. So now we're going to use Solidity. This is a Solidity file. By the way, you'd probably need an extension to show you highlighting of Solidity code. I have this one, but you can choose any one of them. And so now let's write the simple smart contract in Solidity that exposes a uint, public uint, life meaning, and we need a function to set it and a function to retrieve it. So set public, and this is going to set it as the parameter, and function get. And this is a view function and returns uint. And of course, this shouldn't be in the constructor, all this code. Fix this to returns. Typo here, should be uint. Now it's compiling. Okay, so now the next step is to run Truffle compile. And this takes stuff from the contracts folder and compiles the Solidity code. So now the compilation is done and we can see the output in build/contracts. This is an automatically generated JSON file, and you should not change it. It's created automatically. And the next thing we need to do is create a migration. So this is a JavaScript file that is responsible for the deployment of the contract into the blockchain. So the files are run according to the number that is prefixed here. The name doesn't really matter. And this is the simplest form of a deployment. So we are loading the contract and creating a function that will deploy the contract. So this is just basic boilerplate code. So we have a function that calls deployer.deploy with whatever we've loaded from the artifacts. And once the contract changes through the evolution of the software, you just write more migrations, and that records the changes on the blockchain, because nothing really is deleted from a blockchain, right? And now it's time to migrate or deploy our contract. So for this, we need a blockchain. So we're going to load Ganache, and we need to configure. Okay, so we're gonna choose Quick Start Ethereum. This is gonna create a local development blockchain for us. And in the meantime, we can add the necessary settings in Truffle config file. Just need to change the port to the Ganache port 7545. And so now we can see this is basically the Ethereum blockchain. This is a list of demo accounts. They each have a balance of 100 ETH. And we can go ahead and deploy or migrate our contract. Let's see if it works. Now we can see the migration is complete. This was the gas price, and this was the total cost, total deployments. So we can look in Ganache and we can see that the current block has been changed to 1. Transaction count is also 1 for this address. So it just shows the first address. And now we can continue with the client. So in order to write the client, we're going to add a few packages, starting with Web3 Dart. So this package is responsible for connecting to the Ethereum blockchain and reading the ABI interface, which is kind of like an API for running functions that are written in the smart contract. And we can also add provider, which is used to notify the client on changes that happen in the object in our smart contract. And we're going to add HTTP. And the last thing we need to add is WebSockets. WebSocket channel. we can see all the packages here. That's good. And now we can go ahead and just try and run the default app and see if everything is working. So we have a baseline. I always like doing that. Emulator is up. We can find main Dart. Create a launch JSON. And run. And we can see that this is running. One thing we need to add now is loading of the contract in the JSON format from the build folder. So we need to find the assets section and add build contract. I wanted to load any contract that exists in that folder. And we can run it again. So this is failing because I didn't add a trailing slash. Okay, it's running. So now we can go ahead and start writing some Flutter code. So in our lib folder, we can create a new file. This will be the provider that represents our contract. And this will involve some boilerplate code, but we'll go over it and explain as we go. So this needs to extend change provider, which we can import from the class, from the provider class. Change notifier, sorry, notifier, yeah. And so first thing I'm gonna add is the contract name. So we don't have to repeat it over and over. And the IP of the network that we're going to be connecting to. This is required because we're doing it cross-device and not on the same, not from the same computer necessarily. So I'm going to run ipconfig. And so this is my IP address. And we're going to add the same port of the Ganache network. And we need to calculate the RPC URL from all of this. And we also need the web service URL. WebSockets, excuse me. Which is the same, only with a different protocol. And we will need a private key. So this should generally be loaded from a wallet, but in order to simplify this guide, we're for now just gonna copy the private key of the first demo account that was created for us. So I'm gonna copy this and paste the private key here. I'm gonna use that to connect to the to run the operations. So we need a Web3 client, which we will initialize later. This is from Web3 Dart. And we also need the credentials. We need a contract. So we can start with this, and let's create a constructor. That calls an async function. So this is a common pattern. And now initialize can be an async function. So here we're gonna initialize the, sorry, this is closing too early. Here we're gonna initialize the client. So here's the constructor, which receives the RPC URL and a new client. We're gonna initialize it from the HTTP. And we have a socket connector. So here we're using the WebSocket channel with the WebSocket URL. This needs to return string. Okay, so this is the first piece of boilerplate code for initializing the connection to Ganache or to Ethereum in general. The second one is to load the ABI. So the ABI, as I said earlier, is like an API for smart contracts. So the first thing we need to do is load the asset file of the JSON that was generated automatically from Truffle. build/contract/life meaning.json. And we're going to decode this because this is a string, so we're gonna turn it into a JSON, an object. And now we're going to extract the ABI section out of the JSON. And now we can, now that we have the ABI, we can go ahead and create the contract. So first we need to initialize the address. So Ethereum address we want to load it from hex. So we're going into the JSON and extracting the network section. This port and this address. And we can open the JSON file and see that this is the key we're after. 5777 and address. So this is the address we're extracting from the JSON. And here we're initializing the state variable credentials, which we're going to use in later functions. So again, I'm using from hex, and this time it's the private key of the account I'm using in order to call the functions. Contract again is initialized in a state variable. The ABI is contract ABI. I'm loading it from JSON, and the JSON data is the ABI portion that I extracted previously. So this, and the name is the contract name, which is the const we defined up here. And we already have the address from here. Okay, so this portion of the code is pretty much boilerplate, but this is what creates the connection to the blockchain and initializes the credentials and the contract and the client. So now we can write the function that actually does something. So we have, in order to remind you, we have in the contract two functions, get and set. So these are the functions that we have exposed via the ABI, and now we need to call them. So get meaning. So this is async, of course. Client call, that's the calling of the function, and it has a contract, which is the contract that we initialized, and the function. And the okay, we don't have the function yet, so we can initialize two more state variables, which are the contract function, get life meaning, and set life meaning. And now in the initialization, we can initialize their values. So this only needs to be done once on the initialization. Get and set. And so now we can use them. I'm actually gonna call the get meaning function on initialization. So we have the value to begin with when we initialize. So back to the get meaning function. The function will be get life meaning, which we initialized, and no params. Now let's extract the actual number. This will return an array, and we need the first part of it. And we are going to define this as a field in our provider class. This will be a big int, because in our contract this is defined as uint. So the equivalent of that in Flutter is big int. And we can also add a loading. And we can initialize it as true. And after we run the first get meaning of the initializer, we can set loading as false. And then we're going to call notify listeners, which will update all the listeners to the change notifier. This is a bit like calling set state, and it updates the state with these values. Okay, so that's the get meaning function. And we can do the same with set meaning. And we need to receive the value we want to set to. And we're going to set loading as true before we begin. And because we're in a change notifier, we need to remember to call notify listeners, so it will update the state. And because this is a setter, we are not interested in the result. And so, and also because this is a an operation that will update data on the blockchain, we're not going to use call from the client, but send transaction, because we are in essence writing a transaction to the blockchain. So transaction, we're going to create it now from the contract. And the function, which is our set function. And this time we have a parameter which contains the value. And in order to just skip all this code, we can call get meaning again. So this will just update the change notifier with the same value that exists by calling it again from within the blockchain. In real life, you won't probably do a setter and a getter one after the other, because you know which value you set. But we're going to use this as a test just to see that the data was actually written into the blockchain. And so this is our provider. Now we can continue to write the code that shows us the number. So let's go back to our main Dart. Remove the comments. And let's extract the my home page to a new file. And we can import the missing stuff, material. I'm actually gonna run this again. The first thing we need to do is to wrap the material app with a change notifier. provider. This comes from the provider library. And this will allow us to use our change notifier anywhere in the app. So in this current example, we only have one screen, so we're not really using the provider all that much, actually. So we could have done this without a provider at all, but I guess it's a good practice to be able to use this anywhere in the app. We're missing a parentheses, and yeah, so that's the creation of the provider. So when the main Flutter widget loads, before the material app is returned, we have a call to the constructor that we wrote here that calls initialize with the context of the app. And then anywhere underneath the widget tree, we can use it. So we don't need this. And we are going to delete all of the content. And return a scaffold. This is text, of course, and the body So let's first check if, okay, so here we already need to check the loading state of the provider. So let's initialize our provider instance. So this will allow us to call functions that change the state of the provider. And in order to access the updates on the provider state, we need to use a consumer. So this is the Flutter, the basic Flutter provider consumer pattern. This accepts a builder. Move this to the bottom. This will return whatever we had here. And this will get the value, which is life meaning provider. So value is loading. And if it's loading, return a circular progress indicator. And if not, we can return a text that shows the value with the life meaning. This is a big int, so we're going to convert it to string. And this needs a... Okay, so now maybe it's a good time to do a bit of refactoring. So what we have here is... Maybe we can change the name. So this is the life meaning model. And actually this was not a very good name, life meaning provider, because according to the consumer provider pattern, this thing is actually a model. So anything that has state that can be updated via consumers should be called a model. So I'm going to rename this. Name this as well. And we can run this on the emulator in the meantime. So now we can see we have the life meaning model, and we can access the state, the current state of the model via the consumer. A common error is to access this, the provider of the model, and use it for state. But this thing isn't guaranteed to update in an efficient manner. So in order to access the state, you need to use the consumer. But in order to access state modifying functions, you need to access the provider. So that's what we're going to do next. But first we can start testing the code. This is a minimal testing version of the app, and we can start debugging the model and see that we're actually getting the number out of Ganache and that the connection is working. So let's wait for that. So there's actually a problem here. It can't find the contract, and that's because the build folder also contains the artifacts from Truffle and also the Flutter build. So we better separate those first. I'm going to go to Flutter to Truffle config. I'm going to add the field contracts build directory. Let's call it Truffle artifacts. And now let's run Truffle migrate again. Okay, so now we can see the artifacts created in this folder, and in the asset loading, we're gonna change the name of the folder. Let's run it again. We also need to copy this path into the code that is loading the JSON file. And we could also use the const contract name here. And we can add a breakpoint in the initialization code and see what's happening. So we have the initialization of the client, the loading of the ABI file from our new assets folder, artifact folder. And we have the ABI portion of the file. We're initializing the credentials, contract, creating the functions, and let's go into the getMeaning function and see if we get the result. Yeah, so we got the number 0, which is to be expected, because that's the default value and we haven't updated it yet. So the basic connection to Ganache is working, so that's good. And now we can use the live, meaning the provider itself, in order to call to get user input and call the setMeaning function. So let's start writing some basic UI. Let's first start with the column. It's gonna show main axis alignment. No, not in the children. Center. And we're gonna show the text. I'm gonna make it a little more explanatory. Current meaning of life. So this is the new text, and sized box for separation, and another sized box with a width of 200 and a child, which will be a text form field. Which will have a controller. We'll add that in a second. Keyboard type, text input type number, because it can only be a number. And some decoration. What is the meaning of life? Let's create this field. This is a text editing controller. A few commas for indentation. And let's see how it looks like. So we have the current meaning of life and the question. Let's add another separator. And an update button. Elevated button. With an onPressed, which we will write soon. And a child. Save. Another comma. And the onPressed. So this is where we call our provider. Set meaning. What's wrong here? What's going on with the E? Should be async. I'm not going to handle this now, but just in case we can catch the error. And so now we need to take the input controller, the text, and this needs to be converted to a big int. So first I'm gonna convert it to a Flutter int and then to a big int. And after the update, we're going to clear controller. And now let's see what happens when we click save. Let's choose a random number, 42. Save. Okay, now we can see that the current meaning of life was updated to 42, and this is a value that was taken from the blockchain because we called get meaning after set. And we can see our balance is down to 99.99 because there's a cost to all these transactions. TX count now is 3. And if we run it again, so it's now 43, we can see the transaction count is 4. You can see all these blocks written. So this just about wraps it up for the first Hello World Flutter Web3 decentralized app. Super simple contract. We might just want to add one more thing, and this is a test for our contract that will be written in JavaScript. So this is just testing the contract and it has nothing to do with Flutter. Let's write a quick test. We're going to require the artifact. And this syntax uses the testing libraries Chai and Mocha. And if you're used to the syntax, this looks exactly the same, except we use the contract instead of the scribe here. So it is for an individual test. Should read the same value that was set. And that is a function. And we can await the contract deployment. And what deployed and what the contracts function allows us to do is use a Truffle's clean room feature, which redeploys the contract to the blockchain on every test. So you get a clean environment that isn't affected by other tests running. So we can set this for 242, const result, await, life meaning, get, and now we can assert the result equals 42. Now let's try and run this thing. Truffle test. So you can see it's using the same network. And we can see the test is passing. And that's about it for this guide. Hope you liked it. And if you have any comments, please leave them below. If you like the content, please subscribe and to get more of these videos. If you have an idea of what you would like to see next, then please leave a comment below. Thanks, and until next time. Bye.